Hello everyone, welcome to Embedded ARM Dev. In this video I'm going to show you how to set up a pre-compiled cross-compiler on Ubuntu Linux. This is a quick and simple way to get set up with a cross-compiler so we can start exploring binaries that are compiled for ARM. So right now I'm inside VirtualBox using my Ubuntu Linux image. I'm going to go ahead and open up a terminal, so hit Ctrl-Alt-T and that will give you a terminal. Okay, so what we're going to do is install several packages that are going to enable us to start compiling binaries, and we'll also be able to examine them. Okay, so we're going to install two things. We're going to install some stuff that will allow us to do native compilation, and then we'll install some things that will allow us to do cross compilation, and we'll get into what those are. So we are going to use the apt utility to download and install these packages. So in order to get started, we just type sudo and then apt.get and then install. Okay, so we're going to put them all in one line, and I'll talk about each individual one as I put it on here. So the first one we're going to do is GCC. So GCC is the compiler that's going to take your source code and compile it into machine code that the processor will understand. And this particular compiler is the native compiler, and what that means is it is going to compile source code into machine code that is designed for the same computer, the same processor that is being compiled on. This is called native compiling. So if I use GCC to compile a C file here, then I would be able to run it on this computer. And so another important distinction we need to make here is the terms host and target. Now, when I say host in this context, I'm not talking about the VirtualBox concept of a host machine and the VM. Okay, in this context, I'm talking when it comes to cross compiling. So the host is the machine that the compiler runs on. In this case, the host would be this Ubuntu Linux VM that I've created. And the target is the machine that the compiled binary will run on. So when we're talking cross compilation, we would be compiling on this, an x86 platform, and the target would be for an ARM platform. So the binary would run on an ARM platform. With native compilation, the host and the target are the same machine. So in other words, I will compile a source file into a binary that would run on the same machine as the compiler is running. Okay, so GCC is going to allow us to do that. The next thing we want to install is make. So make is just a utility. It's a very powerful utility that people use in a lot of their C projects, and it allows you to automate some of the build processing. And it's something that we'll use in future tutorials. So I might as well just go ahead and set it up right now. So the next one that we want to install is called binutils. And binutils is short for binary utilities. So binary utilities are a collection of utilities that allow us to examine compiled binaries to get some information about them. And we'll use them a lot in our future tutorials, and so it's very useful to have. So this particular binutils will be the native one. So this would be one that we would run on binaries that are compiled for this architecture for x86. Okay, so the next one we're going to install is the actual cross compiler. Okay, so this is GCC tech arm text linux tech gnueabi. Okay, so this one is the cross compiler, and this is what will take a source code on your host platform. So in this example, I'm running an x86, and it will compile it into a binary that will run on the target platform, which in this example is going to be ARM. Okay, so you'll see here that we have GCC is the name of the compiler, ARM is the architecture, Linux is the operating system that we're of the target, and gnueabi. So EABI stands for Embedded Application Binary Interface. The EABI, it defines an interface between the program and the operating system. It defines the execution environment, and it defines like function calling conventions, where data and code are laid out in memory, and how the linker works, and the format of the object files. It covers all of this. Now, another thing I'd like to add is that there is another version of this cross compile out there that has the HF on the end. And so this HF stands for hardware float. And so you would use this compiler if you know that the board that you're going to compile for has the capability to do hardware float calculations. So there's some type of coprocessor on there that provides the ability to do hardware float calculations. And so you would only use this particular compiler if you know for sure that your board supports it. So what this would do is it would create a binary that would use the hardware float capability instead of trying to generate code in software that would do the hardware float calculations. So for now, we're just going to go with this one. You could install the HF if you want to later, and they're just two separate cross compilers, but you'd only want to use this if you know for sure that your board does support the hardware float. Okay. All right, so the next one that we're going to do is the binutils or binary utils for the cross compiler. So if we were to compile a binary that was designed to run on an ARM processor, and then we used this binutils right here, it wouldn't work. It would tell us that it didn't understand the format, or that the binary wasn't formatted properly. So we have to actually use a different one. So in this case, it's going to be binutils tac arm tac linux tac gnueabi. So just like this one right here, except instead of GCC, it's binutils. So instead of GCC, let's go ahead and make this look there. Okay, so it's all down here. So instead of GCC is the first, we have binutils. Okay, so when we install all of these, it's going to give us the capability to both do native compilation and cross compilation. And so go ahead and do this, and this will require admin privileges, so you'll have to put in your password. Okay, so you have to confirm the amount of disk space that it's going to take up. Let's go ahead and hit yes. Okay, now this will probably take some time, so I'm just going to go ahead and let it roll, and then we'll pick up once it's done. Alright, so the next thing we're going to do to demonstrate the compiler is go ahead and create the ubiquitous Hello World application. Okay, just going to go ahead and create this real quick. So, alright, so all this is doing is just going to print hello world and then return. Okay, so I'll save this. Now, so the first thing we're going to do is invoke the native compiler. So this is GCC. Okay, then you have to pass in the target, or the source, I'm sorry, this is the source file. Okay, and then the taco option tells you what you want it to. So the taco is going to tell you the name of the output file. Okay, so normally, if you don't specify it, you'll get a .o, or sorry, you get a.out. Okay, that's the default. So if I were to just compile this right now, and then I do a listing, you would see right here we got this a.out. Okay, but if I do it again, and I do techo, and I'm just going to type hello, so this will be the binary. Okay, then we'll do it again, and you see that there's the hello there. Okay, these are the same thing, right? They just have different names. All right, so the first thing we're going to do, of course, we can try running it, and it just says hello world. Okay, so the first thing I want to do is we're going to use the command file. Okay, and what this does is it just gives us some basic information about the file. So when we run that, we can see here that this is a 64-bit ELF file. ELF is executable and linkable format, and it's what's used on Linux. And we're definitely going to get into ELF files a lot more detail later. But just this, this tells you exactly here. This is important because this tells you what processor, what architecture it's designed for. Okay, we'll get into more of these later when we start to talk. We get a little bit more into detail about this. But dynamically linked is there because we use printf, and so when we say dynamically linked, that means it needs to have the location of printf resolved at runtime dynamically. But we'll definitely cover that in another tutorial later. So we can see here that we've got this file file here, and then it's definitely an x86-64. So now what we're going to do is we're going to go ahead and invoke the cross compiler, so that we'll compile the source code, but it'll be an ARM binary. And so we can do that. So if you just type ARM and then attack, then it goes ahead and fills out the rest, and then we're just going to do GCC. Okay, this is the command for the compiler, and we will pass in hello.c as the source, and then we're going to pass, I'm going to give it hello ARM so we don't overwrite our other file. Okay, so this is going to compile this and create an ARM binary. Go ahead and do that, and then we'll list it. So we see here that we got hello ARM. Okay, so now I'm going to run file hello ARM, and we see that this is a 32-bit ARM. Okay, and this LSB is the Indian. So LSB is the least significant byte versus MSB, which would be most significant byte. I haven't talked about Indianness yet, but this lets you know what the Indianness is of the binary. Okay, and so we can see here that this is compiled for ARM. So if I try to run this, it'll complain, cannot execute binary because execute formatter. Okay, so we can't run this on an x86 because it's designed for an ARM system. Okay, so one thing I want to point out that I probably didn't mention is that I talked about Indianness here, this LSB. So this indicates that it's little Indian, and then the MSB would indicate that it's big Indian. And so that's basically it. Okay, so what you've done now is you've installed a native compiler and a cross compiler under your VM. So now you can compile both natively and cross compile for ARM. And if you were to transfer this hello ARM to some type of embedded ARM device, such as a BeagleBone Black or the Raspberry Pi or something like that, then this would run on that platform. Okay, and one last thing before we conclude this video is I wanted to show you some of the utilities that were installed when we installed all of these binaries, these packages. So if you just type arm-tac and then you hit the tab about 3 times. So these are all of the arm-linux-gnueabi binaries or utilities that were installed. They're either part of the cross compiler or the part of binutils. Okay, and so if you come over here, you can see this is the cross compiler that we're using. And then if you come over here, then there's a couple of different, these are all the binutils, most of them are over here. One we'll be using extensively is readelf, and another one that we'll use is object dump, and possibly object copy to some degree. Strip is one that we'll use. So these are all utilities that we'll use in future tutorials. And so I just wanted to point out that these are some of the utilities that were installed when we installed the cross compiler and the binutils for cross compiler, and we'll definitely be using some of these in future tutorials. Alright, and that's it for this video. Thanks for watching. If you have any comments or questions, please leave them below, and we'll see you in the next video.